It's now time to turn to the defining invention of a modern world, the transistor. This little three-legged device has had as important an effect on humanity as the wheel, writing, and the aeroplane. Without it, we wouldn't have modern computers, communications, or many of the other services that we take for granted in the modern world. The transistor, as we have just stated, has three connections. These are called the base, the collector, and the emitter. The signal on the base controls the current flowing in through the collector and out through the emitter. This is shown on the screen. Transistors come in two types, Npn and Pnp. At the simple level, these differ only in the polarity of their power supplies, which are the opposite of each other. The transistor shown in the first example was an Npn type. You might note that the arrow on the emitter lead in both these types points in the direction of current flow. Of course, as we discussed in video number 59, to act as an amplifier, the signal on the control line, that is the base, must be smaller than the current which it is controlling. In the case of this type of transistor, which incidentally is called a Bipolar Junction Transistor or BJT, the control signal is usually considered to be a current, although this is a first approximation and we'll discuss this in more detail later. We can write an equation for the action of a transistor as IC is equal to beta times IB, where IC is the collector current, or the current flowing into the collector, beta is the transistor current gain or amplification, and IB is the base, that is the control current. In some books you'll find that another symbol, HFE, is used instead of beta. A typical value for beta in the case of a small transistor is in the range 100 to 500, with 200 being fairly typical. This means that the collector current fluctuation is 200 times smaller than the base current one. One point to note is that in component datasheets you may see uppercase letters like capital HFE instead of small hfe. These are typically used to refer to DC values as opposed to the AC signal values, which are denoted in lowercase. You might wonder where IB goes after it flows into the base. In fact, it flows out through the emitter with IC. So IE is equal to IC plus IB. But because IB is so much smaller than IC, we can usually just ignore it in small transistors and say that IC is equal to IE. It should, however, be noted that in large power transistors, beta is much smaller, typically in the range of 5 to 100. The operation of a transistor, which we've just discussed, is its use as an amplifier. However, it should also be noted that it is used sometimes as a switch, and the switch mode is distinct from the amplifier one. We'll discuss the switching application of transistors a little bit later in the course.